Let's look at problem number 2 in the last slide. How many kilojoules are required to heat 90 grams of water at 25 degrees Celsius and then boil it all the way? So now I start at 25 degrees Celsius. So I'm somewhere around here. Note the boundaries. This is 0 degrees. This is 100 degrees. So if I'm at 25 originally, I will be somewhere down here. So I don't have to worry about the ice part because I'm already at water at 25 degrees. The first thing I need to do is convert the 90 grams of water to moles of water because I will be going through a phase change. 90 grams, 1 mole of water weighs 18 grams, and you get about 5 moles of water because I just use 18, approximated there. That's how much water I have. If I am about here at 25 degrees and it tells me to boil it all the way, that means to evaporate it all. So I'm taking water from 25 degrees all the way through this slope line to 100 and then evaporating water from 100 to steam at 100 degrees. That's all I'm doing. So I have 2 steps for this problem. Once again, I don't have to worry about the ice part and I don't have to worry about the steam part on the top because I start with liquid water already and I end up at steam at 100 degrees. It just tells me to boil it all the way. It doesn't say to take it to 150 or 101. It just says boil it all the way, which means just evaporate the water, meaning I will stop at steam at 100 degrees. So my first step is going to be taking that liquid water from 25 degrees all the way to the boiling point of water, which is 100. My Q1 is going to be M times C for water times delta T, because that's where I am. I'm at the liquid. Mass is going to be 90 degrees times 4.184 joules per gram degrees Celsius times, what's my delta T? My final temperature is 100. My initial temperature where I start at is 25. It's going to be 100 minus 25 degrees Celsius. Degrees Celsius cancel, grams cancel. This is going to give me 75 degrees Celsius. So if you do all of that math, you should get 28,242 joules. To convert that to kilojoules, because I'm asked how many kilojoules, once again you divide by 1,000. That gives me 28.2 kilojoules. That's how much water is needed or how much energy is needed to take the water from 25 degrees all the way to 100. Now that I have water at 100 degrees, it will start to boil, and as it's boiling, the temperature is not changing. So I have to use this formula over here. For step 2 then, Q2 is equal to N times delta H vaporization for water. And I calculated to be 5 moles of water times 40.7 kilojoules per mole. Notice that the numbers are positive again because I am now heating it up instead of cooling it off. So every number is going to be positive. My moles are going to cancel. And if you do this, it's going to be around 200. So 203.3 kilojoules. That's my step 2. And I stop there. That's all the question is asking. Taking water from from 25 degrees all the way to steam at 100 degrees. And I just did that. The last part then is to do the total. Q total is only 2 steps, Q1 plus Q2. So if you add both of these up, you should get 231.5 kilojoules. Notice how much energy, how much more energy, and I forgot to point that out when we had both of these values, but look at the previous two problems where we had all 5 steps, and look at how much more energy it takes to evaporate something than even to melt it or to heat it. That's because, think about it, what's happening here in the molecular level, I am taking those molecules in the liquid phase and I am taking them very far apart to breaking them so far apart to enter the gaseous phase, and that requires a lot of energy. So that is why this energy here is the largest of all of them, because it requires a lot of energy to break those liquid molecules apart and take them so far apart that they will be in the gaseous phase. This is the end of the second problem. I will erase this and then we'll do problem number 3.